Okay? Oops, sorry. So we are on, what's it called? Quiz 1.5 to 1.6. What are we doing in problem number 1? We're finding the inverse. And this one some of you are going to be able to do in your head. This is an easier one. Those of you that aren't doing it in your head are going to do it the way we did our earlier example. You're going to switch the variables and solve for y. So I got f inverse to be 7x plus 8 over 5. Did you?
Yes.
And everybody's okay with that. Now it says find the domain of the inverse. Here's the inverse. What's its domain? Think about the test you just took. I don't think I've heard the right answer yet, but maybe I have. All reals. Why are there issues with domain? There are issues if there are radicals, and there are issues if there are variables in the denominator, right? Will this denominator ever be 0? No, it's 5. Are there any radicals in the problem? No. So the domain is all real numbers. Okay? All right. Now, next. It says, consider these equations. What do we call that set of equations? What are those called? Starts with the P, parametric. We got a pair of parametric equations. And we're going to write a single equation in x and y. What do we call equations that have just x's and y's? What's that word? Starts with a C. Cartesian. We call them Cartesian equations. Your job is to write a Cartesian equation. And that's it. That's all you have to do. So who remembers how to do that? Okay, we've got to ditch the t. The t's got to go. So I'm going to look at this top equation. I'm going to say, all right, x minus 3 over 2 equals t. Would you agree with that? So now I know what t equals. So I'm going to step down here, and what am I going to say? Y equals x minus 3 over 2 squared.
Where'd you get? I have some.
Okay, up here's the top equation. Subtract 3.
Subtract 3. Oh, yeah.
And divide by 2.
Okay.
And then I have t by itself, which I then can plug into this equation. This is what t equals, so I substitute it in. And this is what I get when I substitute it in.
All right.
Now, what variables are in this equation? Just x and y. I followed the directions, right? If you wanted to FOIL that out, you could. If we did FOIL it out, you would see oh yeah, that's not 2, that would be 4. What shape is that?
Parabola.
It's a parabola. That's right, it's a parabola. So remember that one day when we graphed these on our calculator? If you graphed this set of equations in parametric mode on your calculator, it would give you the same parabola.
So you could just leave the answer as.
Yeah, that one you could, because there's no simplifying that's going to be able to be done. The bonus, we're going to wait, we're going to get to that in a little bit. Turn it over. Now, I've got another random shape. So this time, we're just looking at a baby triangle upside down, and then a bigger triangle right side up. Oh wait, how many is there? 1, 2, 3. Okay. All right, so now look at A. You you all should be able to draw A. Jason? Yep, what's A gonna do? It's gonna take the picture that you have right there in front of you, and it's going to move everything to the right one. So you're just gonna pick up every point and move it over to the right 1 unit. So it should look like this. Easy enough, would you agree? All right, the second one, oh, it's got a negative, and we know what negatives mean. What do negatives mean? We're gonna reflect. So we just gotta decide which way we're reflecting. Our choices are sideways, up and down. So look where that negative is. Which way is this going to reflect? Upside down. A negative out in front takes you upside down. Across the x-axis. Yeah, that's the real way of saying it. So instead of that little triangle being a down triangle, it's going to be an up triangle. And the bigger one is going to be a down triangle. Is that okay with everybody? Well, there's one more thing we have to learn in section 1.6, and that deals with the absolute value transformations. So, before we do the one on the paper, let's do a practice problem or two, and then we'll do the one on the paper. So if we got a piece of note paper somewhere where you can take a note, that would be great. Let's say we have this shape. All right, so we've got this is our shape. And we are going to do this problem and this problem. They both involve absolute value, but like always, you got to pay attention to where the absolute value is. Here, it's directly on the x, just around the x, and here, it's around the whole problem. We handle these differently. Okay, I'm going to do the whole problem first. What happens when you take the absolute value of something? It makes it positive. So, Brenton, I want you to look at this picture. This stuff is positive. This stuff is negative. These are negative y values down here, right? Actually, you know what? Add on to your picture, because I don't want you to have any confusion. Add on to your picture, put a little circle down there. Now, the V is positive. The circle and the trapezoid are negative. They're below the x-axis. They have negative y values. When you take the absolute value of that picture, everything becomes positive. So the V stays right where it is. The V stays put. I'm doing the absolute value of the whole thing now. The V stays put. But see this little circle here? He has to become positive. So he's going to get folded up. And then this trapezoid right here, he has to become positive. So he's going to get folded up. This is a picture of the absolute value of the whole function. So you're taking notes. You're going to remember You're gonna explain to Isabel when she comes back to school, how do we find or graph the absolute value of the whole function? Anything that's negative gets folded up, anything that's positive stays right where it is. Got it? All right. Now this one is different. To graph f of the absolute value, we redraw everything on the right side of the picture. So simply redraw everything on the right side. Because these are positive x's, and when you take their absolute value, nothing will change. Agreed? So the positive x's have the same picture. Now in the original, if I put in 1, I get 3. If I put in -1, I get -1. And that's fine in the original. But what's going to happen here? Think about it. If you put in 1, you'll be finding f of 1. What if you put in -1? You'll still be finding f of 1. So in other words, the sign on x doesn't matter. So whatever you got with the positive x's is exactly what you're going to get with the negative x's. This is a picture of the f of the absolute value. So basically what did I do? I recopied the right side of the picture and then folded it over the y-axis. Now, you might be thinking, well, what happened to the trapezoid, Mrs. Ford? Sorry, Becky.
Okay.
Gone. He's gone. The trapezoid is gone. When you take the absolute value of x, the negative x's disappear and they become positive x's. So that image ends up over here. So one more time. How do we handle f of the absolute value? Step 1, draw the right side of the picture. Step 2, reflect it across the y-axis. That's it. So now we're ready to do the one on our quiz paper. So we're going back to the original shape we had on the quiz, the old quiz, which was just this. And now we're going to sketch f of the absolute value. So 30 seconds ago, I reiterated those steps. What do we do first? If we're doing f of the absolute value, we draw the right side. So I'm going to draw that big triangle exactly as it is. There you go. I draw the right side of the picture. And then what do? Reflect it over. So I'm going to redraw it on this side. And that is a picture of f of the absolute value. And then y, oh goodness. Or not y, I guess it would be d, but maybe I didn't label it. That last one down there at the bottom.
Can that be the same?
What do you mean, would it be the same?
The same as the original?
I know. I see why you might say that, but think about this for a minute. What impact does this 2 out here have?
Double.
Double what? The height. what impact does this have? Shrinks the width. So the operations sort of seem like they cancel each other out, but they're in different directions, so they don't. So it's going to be twice as tall. Oh, twice as tall. And half as wide. Okay? Now, you can do that in one step or you can do it in two. It's up to you. I'm going to do it in 2 steps. I'm going to double the height first. Actually, no, I'm going to half the width first. So here's my original triangle. This is dashed. Oops. Half as wide.
Wait, that's not the.
Oh wait, that's the wrong picture, isn't it? Yeah, sorry about that. Okay, well, yeah, I'm still looking at that picture. I need to be looking at this one.
It'd be 1.
So let's see. It's going to be 1.5 because it goes over 3, right? It's going to be 1.5. So it looks like that. The triangle does. And then the little one is only 1 wide, so it looks like that. So that dashed thing is this part of the problem. I drew exactly what was on my paper, except it's half as wide. Instead of going over 3, it went over 1.5. Instead of going over 2, it went over just 1. It's half as big. Now I gotta take this picture and make it twice as tall. So I'm gonna go all the way up to what? This is gonna come all the way up to 6. That's supposed to be a straight line. And this is gonna go all the way down to 2. So the green one is the answer to the question. Would you agree with me? Okay, we're gonna eat lunch last today because I've got, I can't remember, 3 or 4 teachers in my department that all teach exactly the same periods as I do. So by adjusting lunch, I can go observe half the class when they come back from lunch. So that's what I'm gonna do today. So we're gonna eat last, but what we're gonna do right now is, the other day I gave you a piece of paper like this. I want you to get it out. We're gonna work in groups. And we're gonna do a little graphic. Okay? So I'm going to video this.